We're going to look here at slope-intercept form really quickly. Now this should be a review and we looked at it a little bit in class, but I just want to make sure there's no confusion. So I want to start with a specific example. So let's say we have an equation for a line and it's y equals 4x plus 3. The 4 here represents the slope and the 3 represents the y-intercept. And the graph is going to hit the y-axis at the point 0, 3. That's why this is called slope-intercept form. Now if we go to our graphing calculator and actually punch this in, so I said 4x plus 3, and I graph this, what you'll notice is that the line hits the y-axis at the point x is 0 and y is 1, 2, 3. So that's our y-intercept. And you'll notice that it has a slope of 4 over 1. So if we choose this point here, and I go up 1, 2, 3, 4, and over 1, we get to the next point in our line. So again, this 4 represented our slope, and the 3 represented where the line hits the y-axis. We can look at another example. Let's say y is equal to negative 4x plus 3. We're going to have the same y-intercept, so it should hit at the point 0, 3. But now my slope is negative 4. And what that means is it's going to go down 4 instead of up 4. So if we put that into our calculator, do negative 4x plus 3, you'll see something different. So now this line is equally steep, but it's going in the downward direction from left to right. You'll notice that it still hits the y-intercept or the y-axis at the point 0, 3, but now we go down for 1, 2, 3, 4, and over 1. So we have a generic way of writing this, and that's y equals mx plus b, where m is the slope and b is the y-intercept, where it's going to hit at the point 0, b. Now b is going to be a number in an actual equation. So if we look at an example here, this is from your homework. I'm going to do number 5 since you're supposed to be doing the evens for homework. And they tell us m is equal to 7 over 2 and the y-intercept is negative 5. So remember, we're looking at y equals mx plus b. B represents the y-intercept and m is the slope. So all we have to do is plug these in to the different parts of the equation. So y equals, instead of m, I'm going to put 7/2 x plus negative 5. And so then I can rewrite that as 7/2 x minus 5. That would be your answer. That's it. If we look at number 7, this is a little bit different because they're not giving us the slope or the y-intercept, but we can look at the graph and figure it out. So if this is my origin, or my x and my y axis here, the first thing I need to do is figure out where does this line hit the y axis. So when x is 0, y is 1. So then I can say b is 1. The next thing I would do is try to figure out the slope. So I'm going to find the next time that it really intersects at a whole number, because that'll allow us to count really easily. And so all we have to do is say it goes up 1, 2, 3, and over 2. So because slope is rise over run, or change in y over change in x, it's 3 over 2. Then we can write out the equation. Y equals 3/2 x plus 1. Now sometimes you're going to be given an equation in standard form, and you're going to have to convert it to slope-intercept form. The way that we do that is we need to isolate y. That means get y by itself. So all we have to do is some basic algebra to do that. I'll do numbers 9 and 11 because those aren't on your homework, but you can use them as an example. So in order to isolate y here, I'm just going to subtract 2 on both sides. And I get negative 5y equals negative 7x minus 2. And then I can divide by 5 on both sides. Remember, you have to divide the whole thing on this side by 5. And you end up getting, negative 5. You end up getting y equals 7x over 5 plus 2/5. I always say pull the fraction out of this term. So that's equal to 7/5 x plus 2/5. So again, if you're given something in standard form, which looks like this, you need to isolate the y term. You need to get y by itself. And then you'll be in slope-intercept form.